In this deep dive, we will talk about unified multimodal chain of thought reward model through reinforcement fine-tuning. We're looking at some really interesting research today tackling a pretty key problem in AI. That's how to build reward models that don't just give a score, but actually understand complex visual and text stuff through deeper reasoning.
Exactly. Current reward models, the ones that guide how multimodal AI systems learn, they often hit a wall with complex tasks. They might say, okay, this image is better than that one, or this answer is right, but they often miss that step-by-step thinking, the kind of granular reasoning humans do.
Right, that lack of deep reasoning can make their judgments a bit shaky sometimes, especially when things get complicated.
Precisely. And that's why this new research is important. It's trying to give these reward systems a much better ability to think things through logically.
Okay, so let's dig into the main ideas here. The researchers put forward, what, two key hypotheses about making these reward models better?
Yeah, two main thoughts. The first big one is that to make a reward model truly reliable and robust, it needs to explicitly use what they call long chain of thought reasoning, CANOS for short.
Chain of thought, like showing its work.
Exactly like showing its work. Instead of just spitting out a final score, it goes through the logical steps. This helps it break down complex visual stuff, text information, look at it from different angles, and then come to a more, well-grounded decision.
So it wouldn't just say image A is better, it would explain why, maybe looking at how well it matches the prompt, the aesthetics, how real it looks, that kind of thing.
That's the idea. And the second hypothesis kind of builds on that. They suggest that once a model gets good at this explicit, detailed connote reasoning, it also develops a stronger implicit reasoning ability. So even when you ask it for just a direct reward score without the whole step-by-step explanation,
Yeah.
that score itself becomes more accurate because it's tapping into this deeper internalized logic it learned.
That's really interesting. So forcing it to think step by step not only gives us better explanations, but also improves its gut feeling, its overall judgment.
Yeah.
Now, the paper mentions it's tough to train models to do this code IT thing. What makes it so hard?
Well, the main bottleneck is data, specifically large-scale chain-of-thought reward data. To train a model to reason out loud, ideally you need tons of examples of detailed reasoning linked to the final judgments.
And getting that data is the hard part.
It really is. Creating that kind of data set takes a massive amount of human effort and time. Imagine someone having to manually write out the detailed reasoning for thousands and thousands of comparisons, not just picking the winner, but explaining why. It's super resource intensive, so just using standard supervised fine-tuning methods becomes a real challenge to scale up.
Yeah, I can see that. Getting a simple, this one's better is one thing, but getting the full rationale every time, that's a whole different level of effort.
Yeah.
So how did they get around this problem? How did they train a model for this explicit Sukhote reasoning without needing endless amounts of that special data?
They came up with a new approach they call unified reward think. They're presenting it as the first unified multimodal long code reward model. And it's designed for that multidimensional long chain reasoning you need for both understanding visuals.
Like judging if a caption matches an image.
Exactly. And also for generation tasks, like assessing how good a generated image or even a video is based on the text prompt.
Unified reward think. Okay, catchy name. What's the core idea behind how it works? How does it learn to reason deeply across pictures, videos, text?
The key ingredient is reinforcement learning. The researchers basically thought, okay, maybe these visual language models, these VLMs, already have some reasoning ability hidden inside.
Latent ability.
Yeah, latent ability. The trick is figuring out how to activate it, how to enhance it. And reinforcement learning lets the model learn by, well, trying things out and getting feedback. It gets rewarded for developing and improving its reasoning process.
Reinforcement learning. So it learns from experience, basically. Can you walk us through the steps? The paper mentioned 3 stages in the unified reward think pipeline.
Yep, a 3-stage process, each building on the last. First stage is called cold start. The goal here is really just to get the reward model used to the basic format, the structure of multi-step reasoning.
How do they do that?
They use a small amount of what they call distilled Coty reward data.
Distilled data, like a concentrated, high-quality set of examples.
That's the idea. And even though it's a small amount, they found this cold start phase works surprisingly well. It helps the model just grasp the basic structure. Okay, here's a sequence of thoughts, and then here's the final answer. And interestingly, they found this learning seemed to transfer across different visual tasks, even including video, which they kind of see as understanding multiple images over time.
Wow, so just a little bit of the right data can prime the pump pretty effectively. Okay, what happens in stage 2, rejection sampling?
So in stage 2, the goal shifts. Now it's about getting the model to produce that COT reasoning more generally across lots of different vision tasks. For this, they use large-scale unified preference data. This is more like the standard data, just knowing which output is preferred.
Okay.
And the core technique is rejection sampling. The model generates its reasoning process. If that reasoning leads to the correct preference judgment and the model seems confident about it,
Uh-huh.
then that sample gets kept. It reinforces the correct reasoning patterns by focusing on the model's high confidence, correct outputs, before they move on to the really heavy lifting in the next stage.
Ah, so it's like saying, hey, you reasoned correctly here and you seem sure about it. Let's reinforce that way of thinking. And does that help save on training costs too by weeding out easier examples?
Exactly. But focusing on samples where the model's already showing some promise in its reasoning, they build a stronger base before tackling the harder stuff.
Mm-hmm.
Which brings us to stage 3, the final stage, Group Relative Policy Optimization, or GRPO. This is for the Unified Cut-to-Reward Reinforcement Fine-Tuning.
GRPO. Sounds like the main reinforcement learning engine. What's the objective here and how does this GRPO thing work?
Right, this is where they really refine the model's reasoning.
Yeah.
The goal is to learn from the harder, maybe more ambiguous samples, the ones that weren't straightforward enough for the rejection sampling phase.
Huh.
And Group Relative Policy Optimization is the RL framework they use. It relies on what they call verifiable rewards.
Verifiable rewards. What makes them verifiable?
Good question. There are 2 main types they use. First is the format reward, which they write as RFNT $. This basically checks if the model's output follows the structure they want. Does it have a thing tag with the reasoning steps?
Okay.
And does it have an answer tag with a final judgment, like image X is better? If both tags are there and formatted right, the reward is 1. If not, it's 0. It pushes the model to actually show its thinking process structurally.
Makes sense. Gotta show your work. And the second type of verifiable reward?
The second one is the accuracy reward, or run-A titers. This one's simple. Does the final answer inside that answer tag actually match the ground truth, the correct preference? If it matches exactly, reward is 1, if not 0, and the total verifiable reward, $20, is just the sum of those two. TOR equals RFMT plus run-A.
So the model gets rewarded for both reasoning in the right format and getting the final answer right. Okay, how does GRPO use these rewards to update the model's policy, its strategy?
So GRPO works like this. First, for a given input, it gets the model to generate several, say, $, different possible responses based on its current policy.
Okay, multiple attempts.
Right. Then each of those $, responses gets evaluated using those verifiable rewards we just talked about, format and accuracy. This gives a reward score for each response. GRPO then normalizes these scores to figure out the advantage of each response, written as not a day. The advantage basically tells you how much better or worse one response was compared to the others in that little group of $.
So it's comparing within a batch of tries.
Exactly. It's a relative measure. Then GRPO figures out how much to update the model's policy. It looks at the likelihood ratio, how likely the new policy would be to generate that response compared to the old policy. To keep things stable, so the model doesn't suddenly change drastically, they clip this ratio. They limit how much it can change, keeping it within a range, like $1 to $1 plus delta.
Okay, prevents big jumps.
Yeah. And there's one more piece, a penalty based on callback-Leibler divergence, or KL divergence.
Yeah.
This penalty makes sure the updated policy doesn't stray too far from a fixed reference model, again, for stability. So the final update step uses an objective function that balances the clipped likelihood ratio, the calculated advantage of each response, and this KL penalty. It encourages responses with high verifiable rewards while keeping the learning process smooth.
That's a pretty sophisticated process, balancing improvement with stability. Okay, so to see if this whole unified reward think approach actually works, they ran experiments, right? What kind of data did they use?
They used a range of data sets. For image generation, things like HBD, OIP, EvilMuse. For checking image understanding, they used a benchmark called VL Reward Bench. And then for assessing both image and video generation, they used GenAI Bench, which has parts for both, and also Video Gen Reward. So a good mix covering different multimodal tasks.
Right, covering the bases. And what did they find? How did unified reward think stack up against other models?
So the results look pretty strong, actually. If you look at Table 1 in the paper, that's image understanding on VL Reward Bench. Their model, even the version without showing the CoPT during testing, they call it ours, was that the full version ours, both showed significant accuracy bumps compared to really strong baselines. We're talking things like Gemini 1.5 Pro, GPT-4o, Alaba Critic.
Wow, okay.
It really highlights that the COPY training helps, because even when the model isn't explicitly reasoning at test time, it's still better.
So that supports their second hypothesis, right? That internalizing the reasoning helps even the direct answers. What about generating images and videos?
Similar story there. Table 2 shows results on GenAI Bench and Video Gen Reward. Again, unified reward. They just call it unified reward. In that table, I think it outperformed other established methods. Things like pic score, video score, image reward, vision reward, lift. The improvements were clear for both image and video benchmarks. It seems effective at aligning the generated stuff with what humans prefer.
Good to see those numbers.
Yeah.
The paper also mentioned ablation studies. What are those, and what do they tell us about how important each part of the pipeline is, and the CAUT reasoning itself?
Yeah, ablation studies are great for figuring out what each piece contributes. Tables 3 and 4 show these results for understanding and generation. They basically took their system apart piece by piece. They looked at the impact of each stage. The cold start, the rejection sampling, and the GRPO. What they found was, well, cold start helps learn the format, rejection sampling helps generalize the reasoning, but it was really the GRPO stage that delivered the biggest performance boost. That's probably because GRPO is specifically designed to tackle those harder cases, the ones the model got wrong before. It forces the model to learn better reasoning pathways through that reinforcement feedback loop.
And did they test how crucial the chain of thought part within GRPO was?
They did. They tried training a version where they took the cache reasoning out of GRPO.
Hmm.
So it was just trying to optimize the final answer directly without the explicit reasoning steps. And what happened? Well, it gave a tiny improvement over the baseline, but nothing compared to the full KISS-based GRPO. That really strongly suggests that it's the process of modeling the reasoning, not just rewarding the right final answer, that makes their method work so well. Just learning from the final answer alone doesn't seem to teach the underlying logic effectively.
That's a really key point. It's not just about getting the right answer, but learning how to reason your way there. Now, they mentioned something about why it's okay to trust the COT reasoning when the final answer is correct during that GRPO stage. Can you unpack that a bit? Isn't there a risk the reasoning is just fluff?
That's a valid concern with large models sometimes, that the reasoning looks plausible but
Yeah.
isn't actually connected to the answer. But the way they set up their Koki process helps mitigate that. They make the model explicitly score the inputs, the image, the text across several different dimensions first.
Dimensions like relevance, quality, etc.
Exactly.
Yeah.
And then it has to aggregate those scores to make its final decision. This structure, this multidimensional scoring and aggregation, forces a tighter link between the intermediate thinking steps and the final output. So because of that structure, when the final answer is correct, it's a much stronger signal that the reasoning leading up to it was probably coherent and logically sound too.
Hmm.
It lets them use that correct final answer signal more reliably to train better reasoning during GRPO.
That makes a lot of sense. If you force it to break down the problem and justify the steps, a correct answer becomes much better proof of good reasoning. You mentioned earlier this unified reward thing builds on a base model, unified reward. What was unified reward, and how does this new work push things forward?
Right, so unified reward was their earlier work. It was a model that unified reward tasks for both image and video, understanding and generation. It showed that training on all these different multimodal reward tasks together could actually help performance across the board. But unified reward mainly gave direct answers, or maybe some shallow reasoning. Unified reward think is the big step up because it explicitly brings in that long chain of thought reasoning. Through that three-stage pipeline, cold start for format, rejection sampling for generalizing, GRPO for refining, it's designed to unlock the more complex reasoning potential that might have been latent in the base unified reward model. The goal is more accurate, more robust, and more interpretable rewards.
So it's like taking a pretty good evaluator and teaching it how to think much more deeply and explain itself. Lastly, the paper touches on societal impacts. What are the thoughts there?
Well, they see potential for this to really improve things like AI-assisted content creation, maybe even education. If you have reward models giving more accurate, more understandable feedback, you could potentially train generative AI models that align better with what people actually want, and maybe models that are more transparent in how they behave, which could build more trust. Of course, they also note the usual caveats about potential biases being learned or reinforced if the training data isn't carefully curated.
Okay, so wrapping this up, what's the main takeaway from this deep dive into the unified multimodal chain of thought reward model research?
I think the core message is about pushing for more reliable and interpretable AI systems when dealing with multimodal stuff, images, video, text. By successfully weaving this explicit, long chain of thought reasoning into reward models, Using that clever RL setup, they've shown a really promising way to get more accurate and robust evaluations. And the bonus finding that this also improves the model's implicit gut feeling reasoning, that's pretty significant too.
And looking ahead, where might this research lead? What's next?
Well, you could imagine trying to scale this to even more complex reasoning tasks, maybe exploring different ways to structure or elicit that chain of thought, and perhaps thinking about how these improved reward models could directly guide the training of generative AI to be more controllable, more interpretable from the start, maybe even exploring fairness-aware training to tackle those bias concerns you mentioned.
Really fascinating stuff. It definitely makes you think, doesn't it? How having AI reward systems that can actually reason complexly could change how we interact with creative AI, and maybe even how we think about getting AI aligned with our goals. Thanks so much for walking us through all that.
My pleasure. It's certainly an exciting area to watch.